This video is going to work through questions 27 to 34 in the review. These relate to the scenario where we're looking at an investigation into whether women prefer facial hair or clean shaven for men. A sample of 150 women who subscribe to a popular magazine were asked if they prefer a man with facial hair or a man who is clean shaven. In the sample, 75% of women preferred men with facial hair. The magazine reported the results of the survey stating that our latest survey says that 75% of all women prefer guys with facial hair over guys with none. Based on this statement, in what population was the magazine interested? So, looking at the statement, they're talking about 75% of all women. So that presumably is the population that they were interested in. Now, was their sample representative of that population? Perhaps not, but that's who they were interested in. When we're thinking about the parameter of interest, the parameter here, we have a categorical variable, right? Whether people prefer whether women prefer men who are facial hair or clean shaven, so categorical. And so we're interested in a proportion, and we're interested in the proportion of the population, so the proportion of all women who prefer men with facial hair. So we're going to have B here. Next thing we're looking for our best estimate of the parameter. The best estimate, remember, is the estimate that we'd take using our sample statistic. So since 75% of women in the sample preferred men with facial hair, 0.75 would be that written as a proportion, and the correct notation would be P hat, because it's a proportion calculated from a sample. We are now going to use an appropriate formula-based method to calculate a 95% confidence interval for the parameter of interest. For a confidence interval for a proportion, we use the best estimate, P hat, plus or minus the Z star value, that gives us the level of confidence we want, times the standard error, which is the square root of P hat times 1 minus P hat over N. Now in this situation, our P hat we know is 0.75. Our Z star that gives us 95% confidence is 1.96. And again, our P hat is 0.75. 1 minus 0.75. Our sample size, we were told, is 150. So we can go through and put this all in the calculator. 0.75 minus 1.96 times the square root of 0.75 times 1 minus 0.75 divided by 150. Gives me a lower limit of 0.68 if I round to 2 decimal places, and 0.75 plus 1.96 times the square root, 0.75 times 1 minus 0.75 divided by sample size of 150 gives me 0.82 for the upper limit of my confidence interval. And just a reminder that the formula itself will be given to you on the exam, as will the different values of Z star that you used for the different levels of confidence. Next question is asking, considering the method that was used to obtain the sample, do you feel 95% confident that the confidence interval you constructed contains the true value of the parameter of interest? So for this, it makes sense to go back and think about what the parameter of interest is. The parameter of interest is the proportion of women in the population who prefer men with facial hair. And we said the population of interest is all women. Right? So do I really feel confident that this particular method of sampling gave me data that is going to make it likely to capture the true proportion of all women who prefer men with facial hair? Now, to answer this question, I need to think about whether or not the sample is likely to be representative of the population of all women. and this is 150 women who subscribe to a popular magazine. This may or may not be representative of all women. Even though the magazine's popular, the people who subscribe to it might be different from people who don't. So I would say no, that this method of selecting the sample might not be representative of the population. Remember that when we're making confidence intervals, we are always doing so with the assumption that we're choosing a sample in a way that represents the population well. If we don't have a good sample, then we can't put any confidence really in our interval that we calculate. Okay. Question 32 asks if the magazine had sampled 1,000 women and found that 75% of them prefer men with facial hair, how would we expect the confidence interval to change? Keep in mind that with a larger sample size, we would have a smaller standard error. And because our standard error were smaller, our margin of error would also be smaller. And so we would end up with a narrower confidence interval. So first of all, we know that it's going to be narrower. Second thing we can think about is that, okay, if the sample proportion is still 75%, the center of the confidence interval is going to be at that sample proportion. So it's going to be centered in the same place, but it's going to be a narrower interval. And you can even check that if you want to by recalculating the confidence interval. 33 asks if we had wanted to use a simulation-based method to make a confidence interval, what type of distribution would we simulate? And the correct answer here is the bootstrap distribution. Remember, the bootstrap is the method that we use to use the data in just one sample to estimate the standard error so that we can make a confidence interval. A randomization distribution we use when we're doing hypothesis testing. A chi-square distribution is not something that's simulation-based. It's something that is formula-based that we use to find p-values for some of our hypothesis tests. And sampling distribution would be what we would have if we took many random samples of the same size from the same population, and that's not what we would be doing here. We'd be using our one sample and calculating a bootstrap distribution. And then the last question in this set asks, where would the simulated distribution, the bootstrap distribution, be centered? And remember that because the bootstrap distribution is simulated by resampling the same data in the original sample, it always ends up centered around the best estimate, because the best estimate is calculated from the same sample data that you're using to simulate the bootstrap distribution. That brings us to the end of this set of questions. We'll pick up with question 35 in the next video.